For this next section, we're going to be solving compound inequalities, so we need to understand the difference between conjunctions and disjunctions. A conjunction means that the values for the variable for which both sentences are true. This is where we're looking for the word and. A disjunction means the variable for either one is true, so here we're looking for or. So, for example, in order for a baby to face forward in their car seat, they have to be 1 year old and they have to weigh 20 pounds. When my babies were 1 year old, they did not weigh 20 pounds, so since both of those were not true, they could not face forward. That would be a conjunction. A disjunction would be like saying, if you're going to stay on your parents' insurance, you either need to be under the age of 18 or you need to be a college student. So as long as either one of those are true, then it would be true. So that would be considered a disjunction. So I'm showing here 3 separate compound inequalities. Any that look like this, right? So I've got 2 inequality symbols. That's going to be a conjunction, right here, conjunction. Those are and statements. So either this inequality is true and this inequality is true. Here, this one is true and this one is true. On an or on a disjunction, you're going to see the word or, and as long as either one of them are true, then it's true. So this is how you'll solve conjunctions. You'll solve it as 2 separate inequalities. So when I solve the first one, I subtract 3 from both sides. And then we divide by -1 on both sides. We do the same thing for the other one. When I graph this, here's -1, there's 5. I need a value of x that's less than or equal to 5, and a value that's greater than -1. So these are the values that make this true. Take a look at the next one, same process. Sorry, that one is a little squished. Here I'll multiply by 4/3 on both sides. And on the other one, if I add 7, I get 3/4. M is greater than 0. There's 0, there's 4. I need a value of m that's smaller than 4 and bigger than 0. So that'll fall right in here. On the disjunction, I'm going to approach this the same way. I've subtracted 7 from both sides. Here I subtracted 7 from both sides and then divided both sides by -1. There's -3. There's 6. Now this is an or statement, so I need a value of c that's either less than -3 or that's greater than 6. So we end up with rabbit ears. try a couple more. The first thing that I might do here is distribute this negative. So I have k minus 1. I'm sorry, divide both sides by negative. I get is less than negative 4. So that means that k is less than negative 3. If I do the same thing on the other side, I divide by a negative 1. I get 1 minus k is greater than negative 4. So that gives me negative k is greater than negative 5. So k is less than negative 5. So there's negative 5, and there's negative 3. And I need k to be less than negative 5. That's an open circle, by the way. And I need k to be less than negative 3. So this is your solution. On the next problem, 2f plus 1 is less than negative 9, or all of this with the decimals. I'll get 2f is less than negative 10. So f is less than negative 5. On this next one, well, I guess you can leave it as a decimal. Also, you might want to think about multiplying through by 10, but actually that's probably not a good idea. So we'll just keep it as decimals. 0.1f is less than negative 0.5. And I suppose it would have been fine because when you divide by 0.1, you end up with negative 5. When we graph it, we have negative 5. Now, I need f to be greater than negative 5 or less than negative 5. But it can't be equal to negative 5. Oh, looks like it can because that's less than or equal to. So here we would have all real numbers.